Okay, so when we draw angles on a coordinate grid, we use theta, which is this little symbol right here, to represent the angle. So we pronounce it theta. It looks like a little circle with like a little line in the middle. And we always draw our angles in standard position. So standard position always starts on the positive x-axis. So angles in standard position always start right here. Okay, so it's called the initial side because that's where we are at the beginning of the angle. Then the terminal side, that depends on how big the angle is. But the initial side always starts right here for a standard position angle. Okay, and if it's between 0 and 360 degrees, which remember 360 is a full circle, that's one spin or revolution around our grid counterclockwise. So if you notice, the angle is opening counterclockwise to the left. That is always how like our positive angles open, is to the left, counterclockwise. Okay, so we can have it stop at 360, but we can also have very, very big angles that are way bigger than 360. That just means that we're spinning around the grid multiple times. Okay, so if we want to draw an angle in standard position, first thing we have to think about is, does it fit between 0 and 360? So example 1, 285, yes, that fits between 0 and 360, so we're going to be able to fit that normally on our grid. Okay, if it's in standard position, it always starts right here. This is the initial side, and then I'm going to open to the left. So we know every quarter turn is a 90-degree angle, so I already went ahead and labeled these with 90-degree increments. Okay, if I want to go 285, that's just a little bit past 270, so maybe here-ish. And the way that we're used to looking at angles, it might look like what we're looking at is this space right here. But it's not, because we have to think about the fact that a positive angle always opens counterclockwise. So if you look at the arrow that I drew in blue here, this is really the angle right here. Okay, so it's very big. It's almost a whole rotation. That's a 285-degree angle. Okay, if we have one like the next example, 520, that's bigger than 360. So that tells us we are doing more than one spin around our grid, but we're still going to start right here. And in order to figure out where we end, we have to get this number in between 0 and 360 so we can see where it's supposed to stop. Because if we look at these green numbers here, it only goes between 0 and 360. So in order to see where it should stop, you just need to subtract 360 from whatever angle you start at. So 520 minus 360 is 160. So that's a more recognizable angle for us. That's definitely in between 0 and 360. That's where we should stop our angle. So that's where our terminal side should be. So just a little bit before 180. Okay, but if you notice in our first example, our arrow just went to this spot. It didn't go all the way around in a full circle. But with our 520, like we were talking about, that's more than one full spin. So I need to find a way to show that I'm going a full spin and then another 160 degrees. So every time you subtract 360 from your angle, you need to draw in a full spin. Okay, and then once you have your full spin, then you go 160 more degrees. Okay, so it's more of like a spiral shape for your arrow. That happens if you have to go more than 360 around the grid. Okay, so every time you subtract 360, that's another spiral you have to throw in before ending your angle. Okay, so if we have 905, that's definitely bigger than 360, so we have to subtract it till we get a number that we can use. So 905 minus 360 is 545, which is smaller, but is still not in between 0 and 360. So we have to subtract 360 again. So minus 360 more, we get 185. This is a reasonable angle because that's between 0 and 360. So my starting side of my angle is the initial side. It always starts right here. And then the terminal side is 185, just barely past 180 degrees. It doesn't have to be perfect, but it does have to make sense. Okay, and then when we're trying to figure out how to draw our spiral, we have to look at how many full revolutions we did before we ended our angle. 2 full spins. So we start at our initial side, we do 1 full spin, or draw like a full spiral, and then another full spin, because we did 360 subtracted twice, and then we finally can end at our terminal side. Okay, and then for the last one, same thing, it's way too big, so we're going to subtract 360. When we subtract 360, we get 765, still way too big, so we'll subtract 360 again. And we get 405, still too big, so we have to subtract 360 again. Then we get 45 degrees. Okay, so you have to keep subtracting 360 as many times as it takes to get a number between 0 and 360, because those are the only ones that fit on our grid. So my initial side is here, and I end at 45 degrees. But I have to make sure I'm putting in all my spins. So I had to subtract 363 times. So when I'm drawing in my spiral, I have to go from my initial side 1, 2, 3, and then finish at 45.